Good morning, class. Welcome to the online classes once again. This is Mrs. Mukherjee. Today I am going to start with the new topic, exponents. Now before I start with exponent, let's quickly revise the few concepts about exponents. First, how do we write the exponents? Suppose I am writing it as a number as 2 raised to the power 3. It means the number 2 is multiplied 3 times, which is actually written as the expanded form is 2 into 2 into 2. So 2 is multiplied 3 times. The exponential form is 2 to the power 3 and the expanded form is 2 into 2 into 2. Now, this 2 here is called as the base. This 2 here is called as the base and this 3 is the exponent, or it is also called as power, or it is also called as index. Now this is how we write the exponents. Now when you have to evaluate, it is 2 to the power 3. The answer should be 2 into 2 into 2 equal to 8. The common error is we multiply 2 into 3, which is not the correct way. We have to multiply 2 3 times. Now this is the simple introduction of exponent. Before we proceed with the exercise, there are certain laws that we should know of exponent. The first law is the product law. Now the product law is written as a raised to the power m into a raised to the power n is equal to a raised to the power m plus n. Now what does it mean? A is one of the number a to the power m and a to the power n. So what we see here, the base is same. Both the base is same as a. So whenever the base is same and there is a product sign between the two numbers, then we can simply add the power and find the answer. I'll give you a simple example. I'll take, say, 5 raised to the power 2 multiplied by 5 raised to the power 1. Then this becomes 5 raised to the power 2 plus 1, which is equal to 5 raised to the power 3. This law is applicable only when there is a multiplication sign. The name itself suggests product law. So when you are multiplying the two numbers in the exponential form having the same base, we can add their the exponents. One more example, if I take say 3 raised to the power 7 multiplied by say 3 raised to the power minus 2, if I am taking, then you can simply write it as 3 raised to the power 7 plus minus 2. So 3 minus 2 is 5, which becomes 3 to the power 5. Now the second law is the quotient law. Quotient law. The quotient law says quotient means division. So whenever there is division, so if it is a raised to the power m upon a raised to the power n, we have to write it as a raised to the power m minus n if and only if m is greater than n. So the quotient law is again the same with the same base. For example, if I take 2 raised to the power 12 upon 2 raised to the power 7, I can write it as 2 raised to the power 12 minus 7, which is equal to 2 raised to the power 5. This is quotient law. There is another way. What if m is not greater than n? For example, if it is written as a raised to the power m upon a raised to the power n, and if n is greater than m, then what we do is 1 upon a raised to the power n minus m. For example, if I take 2 to the power 6 upon 2 to the power 13, I will write it as 1 upon 2 to the power 13 minus 6, which is equal to 1 upon 2 to the power 7. Is it clear? So this goes on like this. If it was a negative exponent, you have to add it, minus minus, it becomes plus. So as we keep on doing the sums, we keep on encountering different type of exponents and how to solve it, but the law applied will be product law, quotient product law, and when product law has to be applied, product law, when quotient law has to be applied is the quotient law. The third law is your power law. Now in the power law, simple power law, suppose a raised to the power m whole raised to the power n, then we simply multiply these two and your answer becomes a raised to the power mn. For example, if I take 2 raised to the power 2 whole multiplied by 3, we don't add these, we multiply, so it becomes 2 raised to the power 6. Or say it was 3 raised to the power 2 whole multiplied by 1 upon 2, then it is 3 raised to the power 2 into 1 upon 2, where this 2 and 2 gets cancelled, it becomes 3 raised to the power 1, which is equal to 3. So this is how the power law goes. Now there is something called as negative exponent. Okay, there is something called as negative exponent, which we should know about. For any non-zero number, if the exponent is negative, it can be written as 1 upon a to the power n. For example, if it was 3 raised to the power minus 3, it is written as 1 upon 3 to the power 3 because of this negative exponent. So the reverse can also be written because they are reciprocal. 1 upon a to the power n can also be written as a to the power minus n. Same thing. Or a to the power n can be written as 1 upon a to the power minus n. Whatever is the number, whatever is the exponent, a to the power n can be written as 1 upon a to the power minus n. This number is positive. If you want to make it negative, you have to take the reciprocal of it. That's it. Is it clear? We'll give some example so that it becomes clear. For example, if I write 5 raised to the power minus 3, I can write it as 1 upon 5 to the power 3, which I gave you an example here. Now, if it was, say, 7 to the power 3, this can also be written as 1 upon 7 to the power minus 3. Okay? This is how the laws of exponent goes. Now, let's move on to the exercise 2A. First question is evaluate. Now, whenever it is called as evaluate, we have to solve. We have to find the final answer. You cannot leave it in the exponential form. I'll do some some questions for you. Part 1 is 3 raised to the power minus 1 multiplied by 9 raised to the power minus 1 divided by 3 raised to the power minus 2. Now here we go about following the BODMAS. So first we solve the bracket. 3 raised to the power minus 1 can be written as 1 by 3. 9 raised to the power minus 1 can be written as 1 upon 9 divided by 3 raised to the power minus 2 can be written as 1 upon 3 to the power 2. Now this is 1 upon 27 divided by 1 upon 9. 3 raised to the power 2 is 3 into 3, which is 9. Division, it means you have to multiply and take reciprocal. So 1 upon 9 becomes 9 upon 1. 9 ones are 9, 9 threes are 27. So your answer is 1 upon 3. Whenever it is said evaluate, this is how you have to completely solve the answer. I'll also do part 2 of this so that you are more clear about it. Part 2 says 3 raised to the power minus 1 into 4 raised to the power minus 1 divided by 6 raised to the power minus 1. You can write 3 raised to the power minus 1 as 1 upon 3. You can write 4 raised to the power minus 1 as 1 upon 4. And you can write 6 raised to the power minus 1 as 1 upon 6. Now this becomes 1 upon 12, and here you can write it as 6 upon 1. So the answer here is 1 upon 2. This is as simple as that. Okay. From the same question, I will do question number 6. So I have done 1, 2, and now I am doing question number 6. Now if you move to question number 6 of part 1, what you see here is 5 raised to the power 2 minus 3 raised to the power 2 multiplied by 2 upon 3 raised to the power minus 3. Now there is no multiplication sign here. There is a subtraction sign. So we can't multiply them. The previous sum was a multiplication sign. So don't get confused because mind is set like that. 5 raised to the power 2 is nothing. 5 into 5. Okay, not 5 into 2. It is 5 into 5, 25. And 3 raised to the power 2 is 3 into 3, which is 9. So 25 minus 9. Multiplied by, now it is 2 upon 3 and a negative exponent. So what we have learnt, that whenever a negative exponent, you have to make it positive. It means we take the reciprocal. So it becomes 3 upon 2 raised to the power 3. 25 minus 9 is 16. Okay. Multiplied by 3 upon 2 to the power 3. So you write it 3 times instead of multiplying, so that easy to reduce. So I wrote it 3 times here. 2 8s are 16, 2 4s are 8, 2 2s are 4. So what is left here is 2, and here 3 into 3, 9, 3s are 27. So 2 into 27, which is 54. So this is how you have to apply on mathematical concepts simply and keep solving exponents and your addition, subtraction, multiplication and division. Now let's move to question number 7 of this. Question number 7. It has a square bracket first. 1 by 4 raised to the power minus 3. Subtraction sign. 1 by 3 raised to the power minus 3. Your bracket closes. Division 1 upon 6 raised to the power again minus 3. Now, negative exponent, what I have told that we have to take the reciprocal. So, 1 upon 4, the reciprocal is 4. The moment you take the reciprocal, your exponent becomes positive. So, it becomes 4 by 3 minus, this will become 3 to the power 3. Is it clear till here? Then division sign, and this becomes 6 to the power 3. Okay. Now, 4 to the power 3. 4 4s are 16, 4s are 64. It's not 12, it is 64. It is not 4 into 3, it is 4 into 4 into 4. So 4 into 4 is 16, 16 into 4 is 64. Minus 3 to the power 3 is 3 into 3 into 3, which is 27. Divided by 6 to the power 3. 6 into 6 is 36. 36 into 6 is 6 6 are 36. 6 3 18 216. Now 64 minus 27. 14 minus 7 is 7. 5 minus 2 is 3. 37 divided by 216. Let's check again. 7 plus 7 14 4 1. Yeah. 37 divided by 216. So you can write it as 37 upon 216 as your answer. Is it clear? Now let's move to question number 9. Question number 9 is 3 raised to the power. Okay, there is a curly bracket first, then a small bracket which is 3 upon 5 raised to the power minus 2, again whole to the power minus 2. Now this is your power law. When it is like this, we multiply the exponents. So what we will do here is, see, again I will read it. 3 upon 5 whole to the power minus 2 whole to the power minus 2. So what we will do here is multiply these exponents. So what it becomes? 3 upon 5, 2 into 2 is 4 and minus into minus is plus. So it is 3 upon 5 to the power 4. Now you can't leave it like this. You have to find the answer because it is evaluate. So 3 we multiply 4 times and 5 we multiply 4 times. So it is actually 3 into 3 into 3 into 3 upon 5 into 5 into 5 into 5. So that what should be the answer? 3 3s are 9 and 3 3s are 9. 9 9s are 81. 5 5s are 25 and 25 is 625. Okay, this is your answer. Okay, I'll move to the last question of this sum. Question number 10. It is 5 to the power minus 1 multiplied by 3 to the power minus 1 divided by 6 to the power minus 1. I write it as 1 upon 5 multiplied by 1 upon 3. Why? Because it is a negative exponent. In bracket divided by 1 upon 6. Now when it is division, it also becomes multiplication with the reciprocal. 1 upon 5 into 1 upon 3 multiplied by 6 upon 1. Now you have seen that I haven't multiplied these two first because I knew looking at 3 that I can reduce it. So it becomes easier. 3 1s are 3, 3 2s are 6. So your answer here becomes 2 upon 5. This is your answer. Now homework for today will be question number 1, all the remaining questions. Okay. Question number 2 and question number 3, I will solve it during our Zoom class so that we are more clear about it. That's for it. Thank you, class.